Oi, oi, oi. We're going to start building the engine, and we'll start with the engine block. It's also called the cylinder block or just the block. We'll call it just the block for simplicity. So the block is a huge part, it's the biggest part of the engine. It's usually made of cast iron or cast aluminium, increasingly aluminium lately. And the block has, its main function is to house the cylinders. And the cylinders is where the piston slides up and down. So that's the primary purpose of the block. It also incorporates passageways for the coolant and for the oil. So the coolant circulates around the cylinders, keeping them cool because they get very hot during the combustion process. And oil circulates through the block to the various places it's needed on the engine. The other purpose of the engine block is it holds the accessories or the auxiliary components for the engine. Things like the alternator, the water pump, the starter motor, the AC compressor. All of those components generally mount to the block because it's good and strong and it can take the weight. This engine block is made from cast iron, which has been the predominant method of manufacturing engine blocks for the last 100 years or so. And the very first engines, very early engines, used individual components, individual cylinders, and a network of brass pipes for oil and coolant, very steampunk looking engines. But those were extremely hard to mass produce, very expensive to make. So when mass production came along, casting engine blocks, which incorporate the cylinders, the oil passages, the main saddles for the crankshaft, all of those made it cheaper to mass produce engines. So for a long time, engines were cast from cast iron, and if you take a look at the surface of an engine block, it's rough, and that's the texture of the sand that's inside the molds from which this engine block was formed. In the last 20 or 30 years, it's become much more common for production engines to have an engine block that's made from aluminium alloy with magnesium or some other alloy. And the reason is those are much lighter. So an aluminium block weighs about 30% the same block in cast iron. It's a massive weight saving. So for manufacturers who are looking to achieve fuel economy or performance, an aluminium block is the way to go. There's one other type of engine block, which is a billet block, which you would only really find in a one-off in the racing world or for restoration. And this is where a block of aluminium is taken, or just a solid block, and the engine block is milled out of that block with all the metal that's not needed basically machined away or drilled out using a milling machine. That's very expensive to do. So you're only really going to find that in the performance world. But in production engines, cast iron, cast aluminium alloy, that's what your engine block's made of. Once the engine's been cast, it's got this rough finish that you see on the unfinished edges. And then it's machined on the surfaces which are important, which join to other parts, or for example on the cylinders. Those parts need to be machined to make them perfectly smooth. I've put the engine on a stand and rotated it round so that we can see the top surface and the cylinders. The cylinders are made in a block. If it's a cast iron block, then they'll be machined directly into the block. If it's aluminium alloy, then it's likely that there will be holes bored and then cylinder liners will be inserted, or those cylinder liners will be inserted into the mold, and then as the aluminium is poured into the mold, it bonds to them and that contains the liners. With aluminium alloy, there's another option, which is a chemical coating which is applied to the cylinders. Nikasil is one name. And that has a similar function to a liner. The reason that liners are used on aluminium is that cast iron is a tough metal which can take the wear and strain on these cylinders. Aluminium, it's much softer, and so a cast iron liner will be inserted. You might also find cast iron liners that are used to repair problems with cylinders. Let's take a look at the surface inside these cylinders. And the surface on a cylinder is vital because the piston moves up and down. We want minimal friction, and the piston must run on a film of oil. We don't want the piston rings to contact the cylinder wall at all. Now, on one hand, we want the cylinder wall to be perfectly smooth to minimize friction. On the other hand, if it's too smooth, then the oil simply falls off the walls. So we need a fine grain in there to provide some sort of grip for the oil. So what you'll find is there's a crosshatch pattern inside a cylinder on the walls, which is formed by a process called honing. And really we want a sort of 60-degree crossover of lines on the wall there to form a very fine diamond shape with indentations that can form pools of oil on which the piston rings can run. I've rotated the engine round again. This top surface is called the deck, and this is the surface that mates to the bottom of the cylinder head. In between this and the cylinder head there'll be a gasket. Here's the old gasket from this engine. So that sits there, and it's the gasket that forms a seal between these two surfaces. So it's important, it's vital that the deck is perfectly flat so that we've got a gas-tight seal, because the top here, this is essentially the combustion chamber. There's enormous gas pressure inside this cylinder at the top, and the head gasket takes the brunt of that pressure. So the head gasket it can conform slightly to an uneven surface, but the top surface here needs to be perfectly flat, and the underside of the cylinder head also needs to be perfectly flat. Now, the engine block is so massive and so tough that it's unlikely to warp. The cylinder head sometimes can warp, and this surface will need to be machined down to make it flat again. But the deck of the block, that's much tougher, and it's less likely to need machining. Now, for an inline 4 and inline 6 engine, there's just a single deck. But if you've got a V-shaped engine or a W-shaped engine, then there's multiple decks. There's one deck for each cylinder head. And if they need to be machined, then they all need to be machined to the same height. Inside the block run oil passageways, which are called galleries. A lot of people call them galleys, but that's completely the wrong word. A galley is the kitchen on a ship. So these are galleries, and what happens is we have an oil pump here on the front. I don't want to go too much into the lubrication system because we're going to talk about that in another video. But we need to roughly understand how this works. So the oil pump is going to pump oil out of the sump down here, up a pipe, and then in here, which is the feed pipe into the engine block. The oil is going to run along here. It comes to the outside of the oil filter, works its way through the filter, goes through the inside of the filter, and then into here, which is a drilled out passageway which runs all the way through the block here. It enters here, and it goes all the way through and then leaves here. And this oil, this main gallery here is the main supply of oil to the rest of the engine. So from this main gallery, we also have a gallery that runs up here and out through a hole here in the deck, which goes up to the cylinder head and lubricates the camshafts and the valve train. And on there's an oil pressure switch. In this case, it's just a switch, which is triggered by low oil pressure and flashes on a warning light on your dashboard. More advanced engines, you'll find a pressure sensor. So that's the main oil gallery, and from here we have little oil passageways, which we can show you, which run down to the main journals and to the jets, which lubricate the inside of the cylinders. So if we take a look at the deck, the oil comes up here through this gallery, and then we've got a oil regulator here, which is a narrow hole, which keeps the pressure in the block nice and high, low down. It's a constricted hole. It's hard for the oil to get through, so that maintains the pressure down here. But that also supplies the oil that's needed to the cylinder head. And then once it's been used in the cylinder head, it makes its way back down through the block, through these return pipes, which basically just drop the oil back down into the sump, and it makes its way around again. So inside the engine block itself, the lubrication mainly happens on the underside. So I'll rotate this around and we'll take a look at the underside. Having brought the engine block round here, we can see the underside. So the engine's upside down basically here. And what we've got these main saddles, which is where the crankshaft sits. It's vital that these get a good supply of lubricant, because the oil not only works here in this bearing, but it also works its way through the crankshaft, which we'll see later. Anyway, there's holes drilled from here down through into this main gallery here. So the oil comes from the main gallery out through these holes where it pumps into these bearings. We've also got on this engine, which is quite an unusual feature for a fairly standard engine like this, is we have jets which receive a flow of oil and spray that oil onto the underside of the piston. and that lubricates the wrist pin of the piston or the gudgeon pin, and it also keeps the piston cold and lubricates the cylinder walls. In other engines, you'll find that as the crankshaft spins, I know we're upside down here, so it's kind of hard to visualize, but the sump would be here and the oil would be sitting in there. The crankshaft would be spinning, and that oil gets flung up and coats all the inside of the engine. And that's what we want. We want the inside of the engine to get a good coating of oil. These jets on this engine, they help that process. So I think what we'll do, let's put the first parts onto this engine block and we'll bolt on these jets that sit here and lubricate the inside of the cylinders. So we're going to install these jets. There's 4 of them, one for each cylinder, and they've got a little locating pin in there. So we'll just drop that in. And I believe there was supposed to be brass washers, but there's certainly no sign of any brass washers when these came off the engine. In any case, we're only going to end up with oil leaking where it's supposed to be anyway. So let's drop that in there and find out the torque specifications for these. So you can see here this oil jet sprays onto the inside wall of the cylinder and to the underside of the piston. So we'll just tighten this down hand tight and then torque it down with a torque wrench. So I'll just install the other 3 jets, one for each cylinder. So what we've got here is this is the engine, it's upside down, and the crankshaft sits inside this bottom area of the engine block. And this bottom area that holds the crankshaft is called the crankcase. So the other thing that's interesting about the engine block is that these main caps, there's 5 on here, that clamp the crankshaft into the saddles and hold the bearings inside. It's essential that these have a perfect circle, perfectly round, perfectly dimensioned bore on the center. And these are cast as part of the block and then bored through all the way through the block, all the way through all 5 of these. And then they're cut off and machined on the ends. And that's my understanding of it anyway. And so what you need to be careful of is that these go back onto the right places, because they're actually formed as part of each one of these saddles. So the main caps need to go back on in their original places. And generally they're numbered, but if they're not clearly numbered, you want to mark them with dots or stamped marks in some way. We pop that back off for now. The other thing that goes on the underside of the engine, don't forget we're upside down here, is the sump or the oil pan, which fits on here, just about there, lines up with its holes and holds the oil. Now we'll talk about this later, but just for now, that's another thing that mounts to the engine block. And on the underside, you may find a gasket. On this engine, we just have an instant gasket, some form of instantly cast adhesive gasket. So that's that. Let's turn the engine back over and talk about the core plugs. On this side of the block, we've got some plugs. These holes, which are plugged, these plugs are called core plugs. Now, a lot of people call these freeze plugs. They're commonly called freeze plugs or expansion plugs, and you'll find them in parts catalogues and places listed as that. But they're nothing to do with freezing really, and it's a common misconception really that if the coolant inside the block freezes, then these plugs are designed to pop out. Maybe that would happen if the coolant froze, but realistically you're going to still suffer some serious problems, most likely, and the block may well still crack. However, freeze plugs, expansion plugs, that's kind of what they're known as, but core plugs is what we're going to call them because that is what they are. And the reason that they exist in the first place is that when the engine is cast using these sand molds, molds are inside and the block forms around that mold, and there needs to be some way to get the sand out of the block, and that's what these holes are used for. The engine is kind of tipped up and the sand is emptied out and washed out, and that leaves us with these spaces inside here for the coolant to run. But the remnant of that is these holes, which are then plugged with these thin metal core plugs. I like to think that when this casting process was first developed, some factory somewhere, a couple of guys were working there and they produced this. And they said, "Oh, what about these ugly holes? What are these?" And someone's thought, "Oh, yeah, we've got to make these are not a bug. These are a feature. If anyone asks, that's in case the engine freezes, the coolant will expand and the plugs will come out. We call them freeze plugs. So that in my mind is how they ended up being called freeze plugs, but that's the way they are. They're a little different from the oil gallery plugs. If you look at the end of the engine here, you can see we've also got a plug here. And this one's for the oil gallery. So oil gallery plugs tend to be small, and on oil galleries, and core plugs will be bigger and all over the place. The other thing to note is that these are thin metal. This block is good solid cast iron or cast aluminium, but these core plugs can corrode, and so it could be a common place for leaks. If your engine block is leaking, it's more than likely the core plug rather than a crack in the block. Luckily, because they're fairly easy to replace, and they're roughly standard sizes as well. While we've got the block round in this position, let's talk about the engine mount, which on this car mounts to these 1, 2, 3 bolt holes in the block. The block's a good place to mount the engine to the chassis. It's super strong, it can definitely take the strain. So on here bolts an engine mount, and that has a rubber mounting which sort of reduces vibration between the engine and the vehicle body. There's various other holes and mounting holes here. These are called bosses, where the surface is machined flat to create a nice flush finish, and the hole is tapped out to give a thread to mount things to. So things like the water pump, the alternator, the air conditioning pump, anything like that is going to be mounted to the block. It's a good strong component. The other function of the engine block is to provide the cavities for the coolant to circulate and cool the cylinders. The reason we need to keep the cylinders cool is because if they get too hot, then the mix of fuel and air can pre-ignite. That is, it can ignite itself before we want it to, before we create the spark. That causes all sorts of problems with timing and stress on the engine components, so it's something we really want to avoid. The other reason is generally when parts become too hot, or generally when they become hot, they expand and that increases wear. So we want to maintain the clearance between the piston and the cylinder wall. And if the cylinder becomes too hot, the piston expands and we can have contact, metal-to-metal contact inside, which we want to avoid. So we're going to circulate coolant around the cylinders through these voids, and generally it's going to flow from the bottom up or upwards. Hot liquids rise above cool ones. So the general flow of coolant you'll find will be from the block of the engine up into the head and then away either from the front or the back, depending on the flow arrangement, and back around through the radiator. A well-designed coolant system should have no air gaps, no voids inside that the coolant can get trapped. Because when you drain the coolant system, you want to drain all the coolant. You don't want to find little reservoirs of coolant left in there. So that's one thing. It's a similar situation with the oil passages.